Okay, this is question 3. There's no context in this question, which in fact makes it easier really. We can see it's a binomial. I can see from my null and alternative hypothesis it's a two-tailed test, and all we're asked to find in part A is the critical region for each tail, getting as close as possible to 2.5%. So be careful on those ones. They're the ones where we don't have to necessarily get below 2.5%. We just want it as close as possible. And then we'll come back to part B. Okay, so let me see if I can show you what we've just done. Okay, so I've started it off for us. So we're given this information, weren't we? 25 trials, probability of success 0.5. We were told it was two-tailed, and we always get this lovely symmetrical distribution when p equals 0.5. So my critical regions will be the same sort of size in each tail. Remember, that only happens when p equals 0.5. I'd expect to get 12.5 successes out of 25. Remember, the expected value is n times p, so I'm expecting to get around 12.5. And then we've just got to find the critical regions, getting as close as possible to 2.5%. Okay, so I've started these off for us. I've used my binomial CD, and I first of all tried probability less than or equal to 9, and that gave me 0.115. So that is too big, that's 11.5%. So then I tried less than or equal to 8, and that gave me 0.0539. So getting closer, but still that's above 5%. We need 2.5%. And then probability of x less than or equal to 7. So I'm going, this is the lower tail we're looking at, isn't it? And that now dips down low enough. And this is clearly closest to 2.5% because this is 2.16%. So that is closest so far. So that there, x less than or equal to 7, is my first critical region. I'll just write it there. So that's the first critical region, x less than or equal to 7. Now remember, because it's symmetrical, I could actually just, work out how far away 7 is from 12.5 and then get the symmetry and work out where this critical region is. And I can just quickly show you, in fact, these are exactly the same values, 0.115, 0.0539, and then so you can see clearly I'm going to get this as my other critical region. This ended up being 2.1. I don't know what's happened to the writing again. Okay, so that's my other critical region there, x greater than or equal to 18. Remember, when you write your critical region, you don't write probability of x greater than or equal to 18. You just write the inequality. Okay, so they're my two regions. That's part A done. Let's go back and quickly look at part B. It was state the probability of incorrectly rejecting H0 using this critical region. Okay, so what that means, if you're incorrectly rejecting H0, that must mean H0 was correct, which must mean the probability of P that you have for H0 is correct. And remember, you reject H0 if you fall in the critical region. So let's go back and have a look. Okay, so I would be rejecting H0, wouldn't I, if I fell in here. if I fell in the region greater than or equal to 18 or less than or equal to 7. Yeah, if I fell in there or fell in there. And we've already worked out those probabilities. So that always the probability of incorrectly rejecting H0 means H0 is true. So that means I use these correct probabilities here. So it's basically the probability of falling in your critical regions. So luckily for us, the critical regions were the same because it was a symmetrical distribution, this one. So I've just simply got to times by 2 0.0216, and you can see then that's simply going to be 0.0432, and I think that is part B and question 3 done.